Okay, so we're going to begin. Thanks everybody who is here. Um, just for bandwidth, please turn off for now, your video and your microphone. If you want to ask some questions while Jonas is talking, please ask via the chat. That would be great. And I'll try to get to those somehow. We'll work on those questions at the end. And well, I want to first of all thank Jonas for being so kind and being able to give us this lecture. I know he was going to be down near in Kansas, and was trying to come down to Oklahoma and do this live with us. Of course, as you know, with all this crisis, he is back in Sweden. But then he sort of agreed to do this via Zoom. So thanks a lot, Jonas. I'm going to read bio very quickly. He has a long bio, so I made it a little bit short. And of course, I asked Jonas if there's anything I miss, he can actually just talk to you about it. So Jonas Lundberg is an active architect, researcher and educator in Gothenburg, Sweden, and London, England. A common denominator for all of Jonas' practice, teaching, and research endeavor is a drive to develop new design technology and innovation capable of mitigating form or adapting to consequences caused by a rapidly changing climate. Jonas works actively with design and fabrication methodology to integrate new digital tools into practice, such as building information modeling, methods of digital manufacturing, 3D scanning, VR, virtual reality, and other new methods. Jonas received a Bachelor of Architecture in 1995 from the University of Kansas. Before studying at the Architectural School of Architecture in London, where we met, where he was awarded the AA Diploma Graduate Design in 1997 and the REBA Part 3 in 2002. Jonas has a vast international experience in practice and pedagogy via his collective Urban Future organization, as well as design and project-based research at the Architectural Association School of Architecture, where he's and the CAS School of Architecture, both in London, and most recently in Chalmers University of Technology in Gothenburg, Sweden. Jonas and his firm Urban Future Organization have won many design competitions, such as the Holcim Sustainability Gold Medal for Europe in 2005, and received the Global Silver Medal in 2006. Recently, Urban Future Organization has worked building high-rise projects with engineered timber. Their Cloud Citizen project shared the top prize in the Shenzhen Bay Super City competition and received worldwide recognition. And of course, there's a lot of many other things that they've done and he's done, but I think this is just a short version of his accomplishments. So, Jonas, thanks again for being here, and I give the microphone to you.
Thank you, Renee. It's great being here, and thanks a lot for the invites. So Renee, Claudio and I, Claudio is one of who's also listening in here. We were all students together at the Architectural Association in London. And we all had a very charismatic tutor. His name is Jeff Kipnis, that you might be familiar with him. And in a lot of the work I think that I'm doing, I'm basically pursuing the idea of heterogeneous space. And I'm going to show that now both in practice, research, and teaching. So I'm actually active in all three areas. So please feel free to post questions in the chat. I think Renee will keep on top of them. So can remind me if I forget something. I'm going to do a slightly different lecture than I had imagined doing if I was there in person at OSU. But I'm going to talk more today about design innovation. So in that process, I will show you more work related both to practice, research, and teaching. So maybe thanks for the introduction as well, Renee, to my CV and so on. So I have been teaching a lot, primarily in London. I've been in a few different places as well, at University of Greenwich, Bartlett School of Architecture, and University of Westminster. And then now I have more or less relocated to Sweden, where I am right now. So currently I'm a faculty at Chalmers School of Architecture and Civil Engineering in Gothenburg, Sweden. And yes, I couldn't travel, so I'm stuck here in Sweden, and we do most of our teaching also remotely. But we are not really as isolated as you guys are. We still can go, kids go to school, and we can do certain things outside, but we're not allowed to travel. So hence, we're going to have to do this remotely. But this is also the way we work in Urban Future Organizations. So we worked online, remotely, actually basically since we started in the late 1990s. Okay, so the title of talk is Design Innovation Between Practice, Research, and Teaching. And bear with me, I have to do this a little bit just to remember my notes. I have to do this on dual screens, but on two different computers. I just have to... Well, basically, I think what we are interested in is this idea of the physical reality and how we experience this, and how design can help us identify and know something about the future, how we can project our ideas towards the future. I think what makes architecture very interesting is the fact that many of the things that we are learning right now are things that we will be implementing, doing, realizing, maybe 25 years from now, maybe 30 years from now. So the things that we learn have, by default, they have to be projected. Because when you finish school, you're basically not a finished architect, but you have to go out and you have to learn and you have to experience, you have to do many things before you get it right, or you get the opportunity to practice on your own. So we are in this very strange discipline, which is not so common actually in today's world, that you get more responsibility, more power, more ability to change the course of the projects that you do with age and with experience. So architecture is one of those strange fields when you're young until you're 50. If you thought about that as in terms of computer science or something, that would be entirely different, right? And we kind of all know this, but I think this is what I'm going to talk about today, is this idea about trying to predict ideas about the future. So today we have a very interesting world when we can, by technology, we can link many different systems together. So we can start thinking about overall ecosystems in a very different way. And of course, this requires a more constructive collaboration between different partners of all kinds. And the building industry and the act of designing and creating, producing projects gets more and more complex. Meaning that our roles are changing and we have to look for other ways of collaborating. This is not entirely new. So when we were students at the Architectural Association, our tutors were encouraging us to think about practice as networks. And we talked a lot about network theory and this idea that maybe you can do things out of a collective will. And this is how we practice today. And in a way, we can see that Urban Future organization that I'm part of, it's a collection of people, of projects, of collaborations, which makes this very entangled web of relationships. So this diagram to the left here is a diagram out of Berg's book, where we featured, where he talks about the Urban Future organization network model as a new form of practice. There were lots of practices that were formed like this in the 1990s, and there are not that many maybe that remain, but it all relies on this idea that together, small people or small practices can do big things together. So even though many of the practices within Urban Future organization are either individuals and small studios, we work on very large scale buildings together. And we do some small projects as well, but why do we work big? But I think we have an idea here that our cities needs to densify. We need to think differently about how we live together, how we can create cities of a new kind, where we can kind of cope with density and proximity between people. Of course, this is something that happens globally, that we're trying to densify our cities and our urban habitats. But I think today maybe we have to question this in the light of the COVID situation, and maybe virus situations in the future may change some of these paradigms. But I think when we think about this, we are a group of people, and most of the members of Urban Future organization, either within the group itself or people that we collaborate with, that we partner with, as in terms of engineering, as in terms of other disciplines, have been working on many different practices, many different constellations, and many of us were participants and active in architectural pieces, in practices that have been quite prominent. And I think what you realized when you worked on these projects were that you were giving up a lot of your energy and your creativity for the greater good of something larger than yourself. In this case, namely another practice. But what we tried to do with Urban Future organization was that we were trying to say, if this means that we are people working together on these projects, maybe we can do this under our own management. And that's kind of what we've done. So we got together, and in that case, our CV is pretty remarkable, because the different members of the organization of UFO have such a broad experience from practice, from research, and from academia. And I think when it comes down to it, I think what we try to do as a practice, it's maybe to challenge some of the kind of conventional wisdoms that we all know so intimately well, right? And maybe in a changing environment, in a changing world, we have to think about this in a different way. So today, maybe we have to look at resources, material, planning. Is permanence good? Is it something bad? Do we want to make things return to nature? Do we want to find cheaper, easier ways to construct buildings? Do we want to question traditional materials? Do we want to think about how we live together in different ways? So these type of questions influence the way that we practice, the way we teach, and the way we research within Urban Future organization. And here, pardon me, this is an illustration. I'm actually not sure the credit has fallen off the image here, but it's basically a student project. But basically what it illustrates is this idea that we got from the type of partners that we have. So we work a lot with a practice, as some of you might know, called Arabs, over Arabs in London. We work with other practices like AKT, Vibira Happold, and so on, that are renowned structural engineers, and in a way they have an attitude towards technology, which is that everything is possible. Just maybe not everything makes sense, but everything is possible to do. And of course, you might have heard, I think it's Charles Baker of SOM, who said, the tallest building that we can build, it's 8,848 meters plus 1, which is basically the height of Mount Everest plus 1 meter. So everything that we can find in nature, today we could actually create, or we could construct it. Now, it doesn't make sense from a materials standpoint or from a resource standpoint, but it is possible. So I think our idea for practice and the way that we try to work on projects also in academia is this idea that technology is, it's not a restriction, but it's rather an opportunity that can guide and enhance the way that you think about your designs. So this idea of technology is coupled with this need that we believe in. I mean, I think some people are still wondering what this has to do directly with architecture. But I think for us, we are trying to look for other models where we question the way we do construction, the way we use materials and resources, so we can create an architecture that gives back more to the environment than what it costs. And this is kind of one of the funding, or one of the principles that we try to apply in the way we think about our projects. And we test this in academia, we develop it in research, and then we try to implement some of these ideas in practice. And thirdly, we have this idea, and I think we kind of are all aware of this, that architects, we don't necessarily build buildings ourselves, but we represent buildings, and we represent instructions, or we produce instructions for other people to carry out our will. And if we only know so much about technology and how we build, maybe that's going to lead to limit what we represent and what we learn how to draw. But it's also the other way around. So this relationship between representation and what we build, it's quite important. So what we try to do is that we try to liberate ourselves to what we can represent and what we can draw. And then at the same time develop the way we think about that technology that makes that possible. And sometimes we think about new technology that necessitates another way of representing the architecture that we are working on. To take an example, we have a design studio at the Architectural Association in London, where the students are working on physical phenomena that approximate the type of complexity that you can find in nature. So maybe, I'll take for an instance, we are dripping wax in water or something like that to create this free formation of solidified wax, which is a condition both of the temperature of the wax, the material itself, and the way it's released, and the temperature of the water, and the fact that it's dripped in water. That, to create that condition digitally, or even in an analog means of representation, would be very difficult. So here our instance, or our experiment, is really to work with physical phenomena that are difficult to represent with current digital or analog representation techniques. And then we try to work out, how do we draw and how do we model these things digitally? And you might be aware of this, that the Industrial Revolution, I mean, you know, the first Industrial Revolution, which was basically the invention of the steam locomotive and basically with industrialization to start with. Then we have what we saw in the beginning or the middle of the 20th century that dealt with mass production, or say the 20th century, that dealt with mass production and the assembly line and the use of electricity. Then we had another one that in a way, the idea of automation, and that we could use robots and we could automate production in different ways. But this is also quite old. I mean, industrial robots may be still the thing to do, still the thing to use in architecture or in many architectural programs, but it's not a particularly new technology in its own right. So it's not really until you get into this level when you have cyber physical systems and where your tools of production are starting to talk back to you that we create some type of new condition. This is something that we try to investigate with some of the tools that we are using. So basically, this is about the second, third, and the fourth industrial revolution, and then this idea that architects, we are primarily working on representation, but it's very important to push the border of representation and the way how we construct things. To go back to in a way where I started, is this idea of trying to work productively or predictively, sorry. So it's really an idea of not trying to just reject whatever happens right now, but to try to find models or parts of models that allow us to look at things in a way that makes maybe the existing models to a certain degree obsolete. This is of course from Buckminster Fuller, from his Everything I Know lecture series. So it's hardly something unique, but if you actually think about that, when you create projects and when you work and you develop concepts, this is a way for us to test the different things that we work on. And of course, this is a picture from Germany in the 1920s, sometimes I think 28 or something like that. And here we have this idea of unproven future technology versus proven technology, tradition. And when we see this image, of course, we know here that the steam locomotive outlived the train that we see to the left. But of course, the people who were standing here waiting for that train waiting for the train, they of course thought at that time that this was the most modern thing they could imagine. And the train on the other side was a distant past somehow. This train is not to the left. It's not as crazy as you think. The propeller is actually not propelling the train, but the propeller in the front is there to reduce the drag of the train. But still, it's pretty crazy to have an open propeller on a train. So that's one thing, to actually not just always embrace new technology, but you also have to have a way of critiquing it and understanding that the novelty and that something is new don't always lead to innovation. It doesn't always lead to something that you can actually use in a different sense. And of course, you are aware of Henry Ford and his legacy. I mean, of course, the thing that most people remember from him is the fact that he invented the automatic assembly line, or the fully automated assembly line. But in a way, what made the Model T Ford so special actually it's the first example of lean construction. The fact that all suddenly a car or a product was made only by industrialized parts or serially produced parts, and the number of parts were limited in number to something that you could show in a diagram like this. So cars before, they had lots of artisan parts, and they had thousands of little parts that were all made by different workshops and different artisans, making the cars incredibly expensive. So today we know something about assembly, that the type of machines we had in the 19th and the 20th century, with the number of moving parts and the number of things that you found, those type of things will be very expensive today. Take Tesla, for an example. I mean, in a way, yes, you have advanced technology, but you also have reduced the number of components and the number of pieces you have in a car. And I think this is something that we can also think about in the building sector, because the way we develop, the way we construct buildings, we keep adding layers to buildings. And every new layer we add, the more expensive, the more complex the construction becomes. So I think what we're trying to do is we're trying to look for models that allow us to question that. How can we reduce the number of layers we have? How can we use materials in a different way that allow for a simplification of the way we build? Or another way of actually reducing the type of complexity of construction that we find. The fact that we are in peak oil, we all know, and we think, however, that this type of environmental predicament that we face, we think there's also an opportunity here to allow us to rethink the way we do things, and that we can put our empathy, our ingenuity and technology at the center of our survival. This is something that Rifkind is talking about in the Third Industrial Revolution. And I think this is something that is quite central, that there are things we can do to make things better. And of course, what I started with was this idea of densification in our cities. This image here is from China, and of course this is super dense. I think this has a nominal height of 100 meters for most of the buildings. And then we know that, yes, we get bigger and bigger cities, and this puts an enormous pressure on our planet. But ultimately, I think the real problem we have in the world is how we're going to feed everyone, how we're going to feed our new population. So what we have to think about is also how we can contain the farm sprawl, the fact that we start turning the world into agriculture. And we have to find other models to think about how we use land. If you go back here, you can take China as an example. That China for a long time, or for actually hundreds of years, maybe 1,000 years, understood that by land or by wildlife or by natural systems, they could not feed the entire population of China. So in China, they had to develop other means. So they started to experiment with raising meat, raising fish, developing things like aquaponics, and other ways of doing farming to make things more effective. And then you also had to expand your what you were able to eat. But this had to do simply with this fact that you had to feed a very large population on a limited amount of land. And I think food, natural resources in that way, there's something that we can think about. But we're also very close to these things that Rifkin calls as pillars of our new world, which is basically we have new fuels. Maybe we can do something with hydrogen. We have new ways of interconnecting things. This ultimately can lead, okay, this is called the third industrial revolution. I think it can lead maybe a step further like this. So Jeremy Rifkin, that you might be familiar with, he's of course with his books also advising lots of governments around the world about how to use technology to change the way we affect our world. So we can change maybe more towards a green economy and so on. And building and architecture can actually be an important part of this. So we've done some work with Arabs urban design. They're no longer Arabs, but before. But we were thinking about using some of these strategies in relationship to buildings. So how you can build smart energy networks, how you can build smart ICT systems, transport, water, waste, also the planning. So all of these things can be interconnected into one type of ecology, or into an ecology. So that's really what we're trying to push. And then this basically it's it's an idea of what we try to represent in architecture. So if we try as students or as architects or as practitioners, researchers, whatever, if we can push ourselves to not be limited to the way we represent things, we can actually work with ideas in a different way. So this is really a very simple thing. This is an exercise we got from my first year tutor in architecture, who basically claimed that if you can draw a stone, you can draw anything. So that you don't limit yourself to the things that you can represent in the beginning, but that it's important for us both in academia, in practice, to evolve the way we represent geometry, form, and buildings in order not to be limited to the modes of representation. So, of course, today you can talk about that in relationship to digital tools. Maybe it's not drawings, but maybe it's modeling. And of course, now we can learn SketchUp, we can learn some other program, we can learn how to extrude lots of geometry, lots of these things together. But there is, of course, something that is an equivalent to the digital kind of life drawing, where you can also learn how to model and use your digital tools to represent things that are not immediately simple and graspable. So this is something that we try to do. So we try to develop the way we can draw and model, so we can actually be part of affecting everything from an initial design sketch to the way we realize that on site. And how we can use maybe augmented technology to bring this digitally from the digital models into the production of a building, into the actual realization and finished thing. And in order to do this, we use a range of techniques today. So we experiment a lot with 3D scanning. We look at different AR technologies, different ways that we can actually interact with instructions, so we don't have to do 2D drawings necessarily. And I'm going to skip this, but we had this, we were part of organizing this architecture and geometry conference at Chalmers a couple of years ago, when we were actually working with this. And then some of these ideas then we try to turn around into student projects in teaching. So this is some master students of ours who developed a pavilion for a very large trade fair in timber construction in Gothenburg, when they got actually paid to build this prototype using plywood. So here it's quite simple. They just had a producer of plywood, and they had a simple 3-axis milling machine. And then we're just trying to develop a range of different ways that could use this. The other thing that we worked on a lot, which you're going to see in some of our work, is it's how we work with solid timber construction, solid cross-laminated timber construction, CLT. So we worked a lot with the way that you actually instruct the machines. So we can actually go in and work with the code on the machines. So we can actually produce timber buildings in different ways. So lots of the practice that we see that we do here in Sweden is based on CLT construction. And I mean, CLT construction to some degree is wasteful, but to some degree we can use material resources that would otherwise go to pellets or to pulp or to energy, that we can actually produce material from it. And then ultimately the idea here is that we can customize the parts, and we can actually replace lots of things that we would otherwise build in concrete with wood. And you're probably aware of this, that there is this big competition going on in the world today about who can build the tallest buildings in timber. And you have this pagoda in Japan. I think it's 1,200 years old or 1,300 years old, where they could build 50 meters in timber already then. And today, lots of tall buildings are being developed using timber. And the one to the right, I think it's SOM, or maybe I think SOMs might be 300 meters, and the 350 meter one is a project in Japan. In the middle of this, you can see what we're doing. We're only doing 100 meters, but we are very much working on this idea of how we can, it's PLP and Nikanseke, for the very tall buildings. And in the middle, we have this project that we've done recently in China, that is trying to push the idea of engineered timber to new heights. And of course, there are many examples of old timber buildings that were quite tall. Today, this building was just finished in Norway. It's 85 meters tall. And of course, here we can replace a lot of use of cement and concrete with timber as a renewable resource. And we have a small, or one of my colleagues have a small engineering practice that help people to work with the engineering of timber buildings. And this we do in order to develop the way that we work with this. So this is some example from other practice, and then I'm going to show you a few things here from what we are doing. So this here is a museum, a science museum in Kaunas in Lithuania. No, in Lithuania. For a second. Anyway, so this is an example again when we were trying to use engineered timber for a public institution. In a way, we wanted to relate this to the way we practice. So we are trying to work globally, but with this same idea of using resources. So this is a small project that we did in at the Dongdaemun Plaza in Seoul. It's basically in this case not using timber, but it's using biofoam. So we can actually cut this building entirely with a hot wire cutter on full scale. And then we worked on some very tall buildings. This is a tower that we won in Shenzhen Bay. It's called Cloud Citizen. And the idea here is really to make a 470, 570, and 670 tower in timber. Actually, here it's more of a hybrid. So we have a hybrid deck and we have concrete cores, but a lot of the rest of the superstructure is all designed to be made of engineered timber. And here you can see this idea, and I think the way we think about the type of spaces we make, I mean, I think you see a lot of ideas of vertical urbanism and so on, but I think in our case here, we are really trying to create a, let's say, a village in the sky, when you have small spaces around these three cores that form the three main parts of the towers. And in this case, this is all a science park. So this is all made for upstarts in IT, in science, both computer software, hardware, all kinds of things, where they want to find a new environment to collaborate. So the client here wanted to find a, let's say, a counter narrative to what you find in the Googleplex or Apple campus or something like that, where it's all one owner, one large corporation that has its own campus. But the idea here is that you put many of these corporations in China into one complex for them to be able to help each other develop. So it becomes a really, really vast building. Of course, yeah, it's made of timber. We were trying to work a lot with how this could generate enough energy so you can sustain some of the digital infrastructure in the project, and how we can integrate other national systems that would also allow for the national cooling of these spaces, because you will have lots of IT infrastructure inside the building. And then, of course, ideas about what type of place does that become in Shenzhen, China, where most of the public spaces have become glass corporate lobbies, where we wanted to extend this idea of the landscape into the interior of the projects, and then for that to extend out in the landscape. So similar idea, this is for another IT cluster, or it's not really that, it's called Tenshuang. It's basically a part of Tencent, which is a big social media company in China, where which also tried to create a landscape that continues into the building, to create not just one homogeneous place or one homogeneous space, but a diversity of different scale spaces that you can enter and then you can move into from different directions. So if you see here in the front of this project, you see this mushroom columns. That's basically a competition for a new museum that was won by MAD. And then our project is right behind that. And we wanted to work out new ways that you can actually work and cooperate. That in a way what they want to do, they want to look for ways that we can work more towards innovation. So you can find collaborations, you can find other ways of working together that could possibly enhance the opportunities for innovation to take place. So in this case, it shows some of the timber structure. So it's basically a more modest building. This is not so tall, but it has 275-meter towers and 200-meter towers. And all of these things are again made by engineered timber. And in this case, we're trying to get around the fire requirement by making a podium that you see here in brown, that it's part of the landscape that is counted as the ground of the city. So we are trying to work with the planning regulations and the building regulations to make it possible from a fire point of view to make tall timber structures within the existing building code. And again, it's an idea of extending the landscape and then trying to find ways of looking at biodiversity inside the building, and to get the building and the system inside the buildings. Here again, it's a lot of digital infrastructure, to find ways that we can actually cool the digital infrastructure. We can use the excess heat from the digital infrastructure for something else. And we can connect that to the natural systems that we are actually growing inside the building. So we work on a range of things. So photovoltaic glass, rainwater collection, natural ventilation, of course, shading, regenerative lift drives. We're working a lot on the different greening processes and the way we can control. And just from another point of view, so we're trying to create this landscape, and then we're also trying to do something different. So if you see all the buildings here in the background, and you know how a glass city looks from a distance, so Shenzhen is mainly steel and glass. There's some concrete buildings as well, but they're concrete and glass. So the whole skyline becomes entirely gray. So here we try to work with materials in a different way. So the structure is made of timber. And then we have all of these terracotta vertical louvers in different colors that are kind of taken from the Chinese. We go from the kind of Chinese palette from terracotta itself to different shades of green that you find in jade and so on, to create a very different color or a different appearance in the type of skyline that you find in Shenzhen. Another timber tower, this is in Stockholm, when we try to use the CLT timbers as an external wall as part of the building. So here we have some of the structural externally on the building. And another tower in Haparanda, Sweden, also working with timber. In this case, it's not so much CLT, but it's a glue laminated construction. And in order to test these things, we use lots of prototypes, ways of testing this on different scales, of course, with 3D printing and so on. And we try to reach out to other people. So this is from Monolite D-Shape in Pisa, when they try to print large in stone. So we're also trying to use some of those things. And some of those opportunities led here to a student project that we then try to bring back into the research. And some of you might have seen this. This is a student of ours at the Architectural Association in London. His name is Magnus Larsen. And he was trying to make a project of the African greenbelt. When you insert this bacteria into the sand, that makes the sand mineralize or become sandstone, basically. And again, other projects when we try to work with foam, with different production, and with students from London Metropolitan University, we did a house for the Solar Decathlon, Latin America and Caribbean, where we worked with this mushroom factory to grow mycelium or mycelia, which is basically the root strata of mushrooms that you can grow into foams of different kinds. So we developed this idea of foam construction now into becoming organic. So the buildings are really alive. And some of our students got to present the work at this dragon den for for the construction industry. And then the latest thing we work on right now is that we are trying to 3D print in cellulose. It's not so original. I mean, now people are working on that, but Sweden have a very large forestry industry, and cellulose is a waste material. So now we are trying to work on that. So that's the type of material research. And then, of course, this idea of working on models and representing architecture, I think, to push drawings, the way we work with data, with mapping, develop the way we draw, the way we represent things, in this case here with 3D scanning. This is a church that we had a student from London Met that scanned just with a mobile phone. It's a pretty good model. And here's some student work from Sangbam at AA, looking at an IT campus. And here we have also some work from the AA, working a lot with representation. And now we also try to then relate this to not just two-dimensional drawings, not just to digital design, but what new opportunities does this allow that we can interact with information in a different way? And we don't have to go through a digital model or through a two-dimensional drawing representation to a building, but that we can find other ways of actually interacting with our space and the way we produce things and the way we actualize, we look at things on site in a different way. So at the moment, we experimented with AA with some students actually working and designing using tilt brush that you might be familiar with. It's been around for a couple of years, but not so many people have been able to use it in an intelligent way. And then we try to find ways that we can use these tools to make sense of this crazily complex process of building that we actually have, with managing all of these different parts, different things, and finding ways that we can actually go from simple design ideas to test, understanding the geometry, to actually instructions of the machines. This is not from ours. Again, I apologize that the credits have fallen off the images. I'm not sure if it's cropping my slides somehow. But again, you know, Grandmaster Kohler from ETH, who's been doing a lot of this. This is from RoboFold in London, when they're working in different robots in tandem, folding metal or steel together. And then here are some examples from this project that we were doing in foam. It's basically a house all made by biofoam. Yes, so it's basically as a test of a building process in full scale together with students. When we actually get to test the performance, and so the equipment you see inside is actually monitoring the actual building. And this is the school where I am right now. So the previous one was at London Met in London when we did it in foam. This is our school at Chalmers in Sweden, where we work on these multidisciplinary full-scale realized projects. So this project was part of the Solar Decathlon in China in 2012, so quite a few years now. But we are working on a new one now for the Solar Decathlon Europe in 2021, when we actually are using 3D printed cellulose that we're going to build in full scale with the students. So we very much try to work on this, both the way that you represent and the way that you think about how you build something. So in this case, this is both a valuable, invaluable learning experience for the students, but also something that we learn immensely from as practitioners. Another thing that we do with this is a project from the AA where we've been working on the relationship between national material and very high tolerances that you get from CNC, for instance. So in this case, the guys at Hook Park have developed a way of scanning the logs, so you can actually register the logs so that you can work with joints on the CNC to a high precision. You might have seen this, the woodshed. So it's all this idea that you take wet timber or nationally grown timber, and then you scan and register them, and then you work on a very high precision detailing on these elements. So I find this research to be quite interesting. And yes, okay, so in a way what we are aiming for is this idea that design has to be regenerative. So it's not okay, it has to be sustainable, to just let it be what it is, but we have to find other ways of allowing our built environment to give back more to the natural environment than it costs. And in order to do this, we have to either learn from nature or use technology proactively to think about this in a different way. And maybe in some cases we have to think about outside the box. I mean, we can think about this in different ways. We can stop eating beef, or we can find a way of making something good with methane, for instance. Not to say that this will resolve all problems, but I think this is the way we actually see these opportunities. We are now this is not a picture from us, but at Chalmers in our media lab, we now have this backpacks, so we can go around and actually experience the digital over the real world. And now we're experimenting with what we can use this for when it comes directly to representation and to the design of buildings. But this is something that we are starting up right now in a project called the Digital Twin Cities. Okay, so why do we do all of those things? Well, I'm going to talk a little bit about why I found these things interesting. This is just kind of before we end. I'm very inspired by this American or Italian-American architect. His name is Paolo Soleri. You might have heard about his arcologies, or maybe some of you have been to Arcosanti or Cosanti in Arizona. But in a way, he was an architect who came out to work with Frank Lloyd Wright in Taliesin West. He didn't necessarily agree with Frank Lloyd Wright about everything. I think he thought Frank Lloyd Wright was a proponent of the suburbanization of America. And I think Paolo Soleri thought about something else.
No, it's just an optional lecture.
Yep.
It's from a Swedish architect.
Yeah. Okay. I think what he was trying to do was he was inspired in a way by his upbringing in Italy with the Italian hill towns, and he was trying to see how you could actually live closer together and how you can combine an idea of architecture into one single project. And it's not the mega city and it's not suburbia, but it's something that they call arcology, which is a combination between architecture and ecology. And this dealt with the way that you could live more communally, you could live closer together, but that you could do that in one architecture. And I think this is old. I think maybe some of his ideas were too premature, but some of those things are actually interesting today when we. So this is something then that we try to drive with our projects. And lastly, I think I just want to stop with this thing that for most of you guys, you're going to be maybe at the pinnacle of your careers, maybe 2050. And that sounds very far in the future. But here in Gothenburg, the urban plan that we are working on currently, it's going up to 2080. So it's actually 60 years in the future. And 2050, the projects that are planned for then are actually very real. So they already know which areas, what they're going to build in 2050. But the point is, I think what we need to do with our education, the way we get with us from our education, is that we need to learn to think projectively about what is practice, what is architecture like 20, 30 years from now, when I'm maybe at the pinnacle of my power in practice or in research or in teaching, wherever you will be. I think it's important then that the knowledge that we get now, it's current even then. So that things that you discuss can actually be relevant. Because once you're out in practice or you have very little time to go back and experiment, and you have very little time to make direct mistakes, because then all suddenly you have the duty of care to someone else. So at the moment as a student, I think it's important to be able to try things, test things, to be able to do mistakes and to do things that you would never do otherwise in order to learn, so you're ready for this exciting career that you have ahead of you as architects. Thank you.